All right, this is exam 1 for Physics 101, fall 2014. The following are not standards for time, however, which one could be appropriate? All right, well, this one's not appropriate because it's not accurate. This one's not appropriate because it's not accessible to everyone, only to the French. This one isn't appropriate because light required to travel 1 meter, I don't even know what that means. Or excuse me, the time required for to travel 1 meter, this just doesn't really make sense. And number 4, however, is appropriate because it meets all of these criteria. And in fact, the speed of light on which this is based is the standard you're used as the standard for the meter. So why not good enough for the second? I don't know. So 4 is the right answer, B. Which of these is dimensionally correct? Well, this one is a kinematics equation, so we know it's dimensionally correct. Let's just so meters per second equals meters per second plus meters per second squared is acceleration times seconds. So one of those cancels there. They're all meters per second. So that's a check. Here we go. Kilograms, meters per second squared, meters per second, 1 over meters, 1 over x, equals kilograms, meters per second. It's cubed, so both are cubed, times 1 over meters squared. So let's cancel some of these things here. I have kilogram, meters over seconds cubed. That cancels. I have kilogram, meters over seconds cubed. So that one's a check. Let's look at this last one. Kilogram, meters per second. That's m times v equals kilograms, meters per second squared. That's the m and the a times 1 over meters. Those cancel. This is kilogram meters per second. This is kilogram second squared. That is not. So 1 and 2 is the right answer. That's D. Consider this expression. Let's see. So 2 is D. This expression, how many sig figs should it have? All right. Well, first I do this addition, and I keep the lowest number of decimal places. That would be 1 decimal place. So it'd be 5.0, and then that's squared. So it's like 5.0 times 5.0 over 2.54. And then I do this multiplication. That would keep the lowest number of sig figs. So that would be 25, keeping 2 sig figs over 2.54. And this has a value, I don't know what it is, but here I have 3 sig figs, here I have 2. I'm going to keep 2 sig figs. That's number 3 is B. Number 4, the current standard for the kilogram is a cylinder in France. What is the new proposed standard? All right, this is a little bit particular. It's not the mass of a silicone sphere in Australia, although there is a silicone sphere in Australia that they're working on. It's not the mass of a silicone sphere that will have a period of 1 second on a pendulum. So that might make an okay standard. It's not the mass. Actually, no, never mind. That would not make a good standard at all because period of pendulum is not dependent on the mass. It's not the mass required to construct a silicone sphere 3 centimeters across. Though they are constructing a silicone sphere of a particular diameter, it's not 3 centimeters, but a particular diameter, the actual standard is based on the mass of a particular number of silicon atoms. And they're constructing the sphere, and then they're calculating the number of atoms that will make up 1 kilogram of silicon. Okay, so A is the answer for number 4. How many centimeters are in a kilometer? All right, 1 kilometer. Converting this to meters first, 1 kilometer is 1,000 meters. And in 1 meter, there are 100 centimeters. So multiplying this out, I get 100,000 centimeters. Here our units cancel, leaving me with centimeters. So the answer for number 5 is B. Pencil is about how many meters long? Well, pencil is actually 20 centimeters long. Actually, pencil is 19 centimeters long, a standard pencil. So that's 0.2 meters. Convert this to British units. So 12 meters per second squared. Let's do the miles, or the meters first, to miles. In 1 mile, there are 1609 meters. And in 1 hour, there are 3,600 seconds. Let's just square this term. And I square that and calculate, I get 97,000 miles per hour squared. So that's not a terribly big acceleration. I mean, this is about the acceleration that you fall at. So it's actually a pretty big acceleration. But in the British system, it seems really big. So A is the answer for number 7. What is the angle theta here? I have the adjacent and the hypotenuse. So I'm going to do my cosine of theta equals 5 over 7. So theta is the inverse cosine of 5 over 7. Just a second. Let's see, 5 over 7. 44 degrees. All right. If you use the radian mode, you won't get the right answer at all. It's not even on there. What is the distance x? I know that 5 squared plus x squared equals 7 squared. So x is equal to the square root of 49 minus 25, which is 4.9. So B. 10, which the following weighs about a pound. Well, a kilogram is about 2 pounds. So 1 pound is about a half a kilogram. What are the units of this equation? Meters per second, that's V. Kilograms, meters, second squared over meters, that's my 1 over A. Let's get rid of that, and that. I'm just left with kilogram, meter, seconds. That's D for number 11. You travel from point A to point B. What's your displacement? Remember, displacement is x final minus x initial. That is minus 1 minus 3 is negative 4 meters. So B is the right answer for 12. All right, consider this position versus time. What is the average between 15 and 25 seconds? So I'm looking here, and I'm looking, let's see, where's 25? 25 looks to be right there. So I think it's right there. So I want to know what is the average velocity. So average velocity is delta x over delta t. That is going to be this position, which is 10. That's my final position, minus this position, which is 30. That's my initial position, over my change in time, which we said is 25 and 15 seconds. So that's negative 20 over 10, which is negative 2 meters per second. So C is 13. Previous plot, what is the instantaneous velocity at t equal 8 seconds? So 8 seconds occurs right about here. So I just want to know the slope of this line right here, because the instantaneous velocity at that point is equal to the slope of the whole line. My run here is 10. My rise here is 30 minus 0. And so rise over run, that's going to be 30 over 10. That's meters over seconds. Our 3 meters per second is positive. So 14 is C. Car is traveling at 20 meters per second. Slows down at that rate. How far does it travel? Okay, so V naught is 20 meters per second. We'll call it positive. It doesn't really matter. What does matter is that you get it right, that the acceleration is the opposite because it's slowing down. So the acceleration is negative 10 meters per second squared, and it travels for 2 seconds. How far does it travel? So I want to know x. V naught t plus 1/2 at squared. That's going to be 20. Negative 10. If you put positive 10 here, you'll get the wrong answer, obviously. 2 seconds squared. That's 40 minus 5 times 4, which is 20. That's 20 meters. So A is the right answer for number 15. Consider the object in this position versus time graph. Which following best represents the velocity versus time graph? Remember, the slope of a position versus time is the velocity. So here I have a big positive velocity, and here I have a small positive velocity. Now because it's positive, that gets rid of this one and this one. So I'm either stuck with B or C. This one initially has a big positive velocity, whereas this one had a small positive velocity initially. And since I'm looking for a big one here, C is the right answer. So 16 is C. Throw a ball up with an initial velocity of 10 meters per second. How long does it take to return to you? So I have a ball, it goes up, boop, 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 back down again. It takes, or you have an initial velocity equal to 10 meters per second. I know the acceleration equals negative 10 meters per second squared. All right, so the acceleration, it takes for every second, the acceleration change, or the velocity changes by 10 meters per second. So you can probably just intuitively know that it takes 1 second to go up and 1 second to go back down, which would give us a total time of 2 seconds. But if you can't intuit that, we can look at our kinematics equations. V equals V naught plus AT. All right, at the top, the velocity equals 0. Our initial is 10 plus negative 10, that's my acceleration, times t top. That's the time to get to the top. And then you solve for this and you find that t top equals 1 second. So it takes t equal 1 second to get here, and then another second to get down here, so that's t equal 2 seconds. For the ball in the previous problem, how high does it travel? All right, so I'm just using my kinematics equation here. What was my initial velocity? Was 10 meters per second. I've already found that it takes 1 second to get up there. That's my acceleration due to gravity times 1 second squared. So that's 10 minus 5, or 5 meters. So 18 is B. So this velocity versus time graph, estimate the acceleration at t equals 4 seconds. So I'm looking for the instantaneous acceleration, and so I want to find the slope of the tangent line. That tangent line is going to look something like this. All right, you might get a slightly different tangent line depending upon how you draw it. All right, now I want to find the slope of this tangent line. Let's see, I'm just going to find the slope of this triangle. You might pick another one. And this is sort of an estimate because you might draw a different tangent line, but you should still get an answer that's discernible between the answers that are given. And let's see, I'm going from 1 to 14, so that's 13 is my rise. And here I'm going from 2.5 to 5, so my run is 2.5. So my slope is something like 13 over 2.5. See, I get 13, I get 5.2. And actually, my rise was negative 13, so that slope is a negative 5. You can tell that obviously that is a negative value. And so that gives me the right answer here, which is going to be E for number 19. And then on the next one, I want to know what is the total distance traveled between t equal 2 and t equal 5 seconds. Let me change my color here. So between t equal 2 and t equal 5. Remember, I want to find the area of this graph. Okay, sorry for the interruption, but let's say I want to find the area under this graph between t equal 2 and t equal 5 seconds. What you want to do, you're just estimating it, but you want to find the area of these squares right here. And the area is 1 unit on this side, right? It's going from 2 to 3. And then 0 to 2, 2 units. So each of these little squares has an area of 2, right? Just looking at the units. So, and then I count the number of squares. So each is 2. So I have 1 square, there's 2 squares, 3, 4, 5, 6, 7, 8. And then let's see, 9 filling up this square, maybe this one, and then 10 filling up this square along with this one, and then we'll say 11, and then sort of combining this one as well. So there's about 11 squares total. So if I have 11 squares times 2, that means I have a total area of 22. And of course the units for this are meters. So let's see what our options are. Okay, looks like 23. I actually calculated the distance, and the actual distance with this function is 23, but 22 is a good close estimate of that, just finding the area. So number 20 then is B. All right, number 21, this was a homework question actually. Truck covers 100 meters. in 10 seconds while slowing down to a stop. So that means that v final is equal to 0. I don't know v naught. Excuse me. I don't know v naught. It's not 0. It's something else. And I don't know the acceleration. So let's write our two equations down. I have here v equals v naught plus at. And then I also have x equals v naught t plus 1/2 at squared. Now notice both of these equations have two unknowns in them. So I'm going to have to substitute one into the other. All right, so I'm going to solve this equation for a. I'm solving it for a because I want to eventually solve for v naught. And so I want to put a in terms of v naught. So a is equal to v minus v naught divided by t. V is 0, so I'm just going to say it's negative v naught over t. Right, and I'm going to take this, I'm going to plug it in right here. All right, so I have x equal v naught t plus 1/2 negative v naught over t times t squared. One of these t's cancels, and then I can put in some numbers now. So I have 100 equals v naught times 10 plus 1/2 of negative v naught times 10. 100 equals 10 v naught minus 5 v naught. So 100 20 meters per second. So 21 is C is the right answer. Your speedometer measures which of these? Measures speed. When throwing a ball straight up, which of the following is true about the velocity and the acceleration? Velocity equals 0. Acceleration is not 0. We talked about that. That was straight from the concept test. Actually, these string are actually from the concept test. As the two rocks continue to fall, what happens to their velocities? You drop a rock off a bridge, you let it drop a little ways, you drop a second rock. Their velocities are both going to increase at the same rate. Now, the first one that you dropped will actually be traveling faster, but its velocity will still be increasing at the same rate of minus 10 meters per second squared. Or you drop a ball from a certain height, push down to the ground. Which of these is the velocity versus time graph? Well, initially it has a velocity equal to 0. And then it gets a big negative velocity. All right, so the velocity is 0 initially. All right, so that gets rid of this one and this one because neither of those have a 0 velocity initially. And it get a big negative velocity. So A is the right answer. Which number is that? 25 is A. 26. Which of these best describes the acceleration? Okay, I have a negative velocity because the slope is negative. And see how the slope is decreasing. So I have a decreasing speed, slowing down. That means the acceleration has to be the opposite direction, which means it has a positive acceleration. So C is 26. Car is initially at rest and accelerates at a constant rate. In the first 10 seconds, it travels 100 meters. How far has the car traveled after 20 seconds? That is, you're doubling the time. I made a note about this in class, but you double the time. Or excuse me, no, I'm sorry, no note. You double the time. How is the distance affected? Well, I know that x equals 1/2 at squared. If I double the time, I quadruple the distance. So it initially traveled 100 meters, and then if I double that time, it'll travel 400 meters. So 27 is B, and here, whatever version you have, is A.